In this video, we're going to look at how a sailing boat works. There are three sections. Firstly, we'll look at how the sail generates power from a wind. Then, we'll see how to utilize the power to make the boat go. And finally, we'll look at how we can sail at different angles to the wind. A sail that is flapping is not generating forward power. A sail is controlled by a rope called a sheet. The sheet controls the angle of the sail compared with the boat. If we sheet in, we pull the sail closer to the middle of the boat. If we ease the sheet, the wind will take the sail further out of the boat. If we sheet in, the sail will stop flapping and take on a curved shape. So let's look at what the wind is doing with the sail. The sheet is not like an accelerator. Pulling it more and more does not mean you're going to go faster. A flappy sail is an unhappy sail, so sheet it in and make it grin. A sail can work in two ways. Let's assume in our immediate vicinity that the air molecules are all travelling in straight lines. Here's our sail, now sheeted into a curved shape. On the inside of the curve, the air is getting squeezed together, creating an area of relative high pressure. On the outside of the curve, the front of the sail, the air is spreading out to fill the available space, creating an area of relative low pressure. As the high pressure wants to equalize with the low pressure, our driving force is created at approximately 90 degrees to the sail. This is what's called a laminar airflow. The other way you can generate power in a sail is to expose the full surface area to the wind. Wind hits the sail and can't get through it, so it swirls around the edges to fill the gap in front of the sail. The result is the same, but relative high pressure is created on the inside of the sail and low pressure created in front of the sail. Again, we create a driving force at roughly 90 degrees to the sail. This is called a turbulent airflow. Now that we know what the sail is doing, let's put a boat into the equation. As we have to trim the sail relative to the wind, the power from the sail does not always go in a direction that we want the boat to go. Therefore, we need a board or keel in water to provide lateral resistance, that is, to restrict the boat's sideways movement so it's able to go forwards. There are several types of board. A centreboard rotates in and out of a boat on a pivot. A daggerboard slides up and down. And a keel has a weight on the end. You can also get centreboards that are weighted and keels which lift up and down. But just remember, the purpose is the same, to provide lateral resistance, that is, to stop the boat sliding sideways in the water. We can split the power being generated by the sail into two parts. Some of it is pushing the boat forwards, some of it is pushing the boat sideways. I have shown the relative forwards and sideways elements of our sail's power, so we can see how they change as the boat turns at different angles to the wind. As we turn the boat closer to the wind, we have to sheet the sail in more, and the driving force of the sail is mostly pushing the boat sideways. If we turn further away from the wind, the driving force is now mostly pushing the boat forwards. We don't want the sail to go forwards of a 90-degree angle to the boat, because at that angle the sail is pushing the boat forwards as much as possible. So if we now turn the boat with the wind directly behind us, we're changing the angle of the sail to the wind. This is now changing the airflow from the previous laminar airflow now to a turbulent airflow. Also, the sideways element of power has pretty much disappeared entirely. For these two reasons, sailing with the wind directly behind the boat can be one of the less stable angles to sail at. Let's now look at the sideways force on a boat. We're now looking at a boat from the front or back. The sail creates a sideways force on the boat. The board or keel restricts the sideways movement. The combination of these forces creates a rotational force which is trying to capsize the boat. This is called the heeling force. So how do we stop the boat from falling over? Well, we get in it. There's plenty of hilarious videos on the net of people getting into small boats and falling in. So what's happening? Well, our weight is pulling down on one side of the boat, creating a rotational force. This acts like a lever to create what we call a righting moment to counteract the heeling force. The further we can lean out over the side of the boat, the more leverage we have, and the bigger the righting moment gets. If we move towards the middle of the boat, our righting moment decreases. We therefore need to move about in the boat to balance the heeling force. The closer we sail the boat to the wind, the more sideways force there is, therefore the more heeling force, so we have to lean out more to balance the boat. As we turn away from a wind, the heeling force reduces, so we don't need as much righting moment and move into the boat more. While you're getting to grips with all the basics, aim to keep the boat as flat as possible all the time. On a yacht, forces are larger, so our body weight isn't enough by itself. This is why they have a keel. As the boat leans over more and more, the sails generate less power and the keel less resistance because they become decreasingly exposed to the wind and water. Therefore, the heeling force reduces. The righting moment on a yacht comes from the keel. The large weight on the end also acts like a lever to pull the boat upright. The more the yacht leans over, the bigger the lever gets, so righting moment increases. In practice, a yacht will lean over until the two forces balance out. This is why yachts sail leaning over. This diagram represents the different angles we can sail our boat to the wind. Obviously we can point our boat at any angle, but these specific angles have recognised names, so we're able to chat about it in the bar. We call these the points of sail. There are a couple more, but this will get us started. Since we can't see the wind, it helps to know that in general, waves formed by the wind will travel in lines in the same direction as the wind, giving us a point of reference on the water that we can see. It is physically impossible to sail directly towards the wind, as we cannot create forward power from a sail. The best we can manage is about 45 degrees either side of the wind. The angle varies slightly from boat to boat. The area that we cannot sail into is called the no-go zone. The closest angle that we can sail is called a close haul. This is where we have pulled our sail in all the way and the boat is at the correct angle to the wind to achieve a laminar airflow across our sail. Starboard and port are nautical terms for left and right. We are on a starboard tack if the sail is set on the left or port side of our boat, so the wind is hitting our right or starboard side of the boat first, and vice versa for port tack. Let's see what a close haul looks like in practice. Notice here, I've got the sail in tight to sail as small an angle as possible to the wind. I'm making minor adjustments of my steering in the sheet just to control power to keep the boat flat. Because the sail's in tight, there's a lot of heeling force, so I'm leaning out fully using the foot straps. You can see that the boat is cutting into the waves at about 45 degrees, which is what we would expect if we're sailing on a close-hauled course. Sailing on a close-hauled course is hard work and boat speed is relatively low. However, being able to sail into the wind is one of the most important skills to master when we're in a boat. That way, we know we're always going to be able to get home. At 90 degrees to the wind, most people's first sail will be on a beam reach course. This is because we can sail across the wind in one direction and come back to the start sailing at the same wind angle but on the other tack. Let's see it. Notice that the boat's course is on a line parallel to the waves. The sail is further out. I'm not having to lean out as much, and the boat's actually moving more quickly than on the close haul. You can also see that I pulled the daggerboard up slightly because we don't need as much sideways resistance. More about this in my next video about the 5 essentials. There's a bit more wind here, so I'm having to lean out a little bit more. But you can see I'm making small adjustments of steering and the sail to balance my power and keep the boat flat. With the wind at a 45-degree angle behind us, we're on a broad reach. This is usually the fastest point of sail. We still have a laminar airflow on the sail, and the power is predominantly taking us forwards. This is what it looks like. We can see the boat is going through the waves at a 45-degree angle. The sail is right out, I'm sitting further in, and I'm just letting the boat roll a little bit with the waves. Look how easy it is here on a broad reach to get good forward boat speed without the hard work of having to lean out. If we have the wind directly behind us, we are on a run, or we are running with the wind. This is generally the only point of sail where we have a turbulent airflow on our sail. Since the wind is directly behind us, we can set the sail on either side and still continue in the same direction. Let's see that on the water. The boat is going along with the waves. The sail is right out and I've moved right in. Looking backwards helps to see what the wind is doing, so you can see the gusts coming. You can see the boat is much slower here, hardly going faster than the waves, compared with the broad reach where I was overtaking the waves downwind whilst staying a much further diagonal distance. This is because the turbulent airflow we have on a run is less powerful than the laminar airflow we have on the other points of sail. We also have what we call apparent wind, which is something I talk more about in my next video along with the 5 essentials. I hope this helps to understand what's going on in the boat. There are other useful videos on my channel, so please subscribe, hit that like button and comment below about what else you'd like to see.